Hello everyone, I am Real Yonetani at Omron Sinic X Japan. Today I'm going to talk about our recent work, Adaptive Distillation for Decentralized Learning from Heterogeneous Clients. This work is done in collaboration with Jiaxin and Zahid, who was an intern student of our team in the last year. Suppose that you want to train a deep neural network for classification tasks, but you don't actually have label data. Then you found that people in the world have relevant data that are also annotated. However, getting direct access to the data is difficult due to privacy concerns. Then the question is, how can we leverage such decentralized and reliable data for training your neural net? One promising approach to this end is federated learning, or FL. FL is a kind of collaborative learning between the server and many clients. Specifically, the server first distributes a global model that we want to train to the clients. Then, the client updates the global model individually using their own data. After that, the client sends the trained data back to the server. Finally, the servers aggregate these client models to obtain a better global model. By iterating these steps multiple times, we can obtain a high-performance global model. While FL is promising, we observe that it has several limitations. First, all the clients are assumed to train a global model of the same architecture. This is, however, not very practical, especially when clients have different hardware. For instance, the case where the client A has GPU while client B has only CPU, and so on. Also, FL requires the server and clients to keep communications to exchange their models. This is also hard for some situations where stable network connection is not guaranteed. So in this work, we address these limitations. Namely, we allow each client to train models of different architectures. Also, we aim to allow clients to share their trained model only once. To this end, we propose a new learning framework, Decentralized Learning via Adaptive Distillation, DLAD. The key idea of DLAD is to extend the technique of network distillation with adaptive aggregation strategies. Specifically, we assume that the server and client are given a plenty of unlabeled data, which we call distillation data. For each sample in the distillation data, we compute the output from each client model and aggregate them in some way. Then, the server trains the global model with the distillation data in order to imitate the aggregated output. Because we only care about the output, each client model can take different architectures. Also, we don't have to ask clients to send model multiple times. An important technical point is how to aggregate client model outputs. Each client trains different models, and the client data are also different. So the servers need to judge which clients are more confident about the current input data and adaptively emphasize the output accordingly. To address this problem, we ask each client to train an additional classifier. This classifier is trained to distinguish the client data from distillation ones. Once trained, each classifier score for each distillation sample shows how confident the clients are about the output. So we use these classifier scores as the aggregation weights. Here are some results. We trained the neural network on CFR'10. Here we split the trained data into separated client data to simulate the decentralized situations. Because each client originally owned a limited amount of data, the original performance of client model, shown in black bars, are quite limited. On the other hand, our approach performs significantly better, as shown in black bars.
We also confirmed the effectiveness of adaptive aggregation under a variety of conditions. So that's all. For more details, please visit our virtual poster. Thank you.